we're gonna go over this really quick. And this video is basically for Ruben saying the stuff that I was talking about was gibberish. The things that I'm concerned about when I'm testing and documenting a loop are the inductance, the DC resistance, and the insulation resistance. So inductance is a measurement that we use for a coil and how well its properties work to whatever we're measuring. So in this case, how well it holds current, because current lags a voltage in an inductor, which I'm sure Ruben knows that. So we're going to test inductance. The common device that you would use to do that is actually an LCR, which measures inductance, capacitance, and resistance, which is reason why I was saying just press that button over to R and you could test the DC resistance as well too. And what that allows you to do is, if you have a good insulation test whether you actually have continuity in the loop, because you can have a good insulation test and actually no continuity on the loop. And that's why it's flawed to go to your Megger first. I'm not saying that it's the wrong thing to absolutely do, because it could be in this process, but it's the wrong thing to do just by telling people to do that and not understanding that DC resistance or continuity is actually an important factor. So in inductance, the algebraic equation or algebraic representative that we have for that is H, obviously old fat white guy named Henry, is where it comes after, just like a lot of these Volta and stuff like that comes after. So you would use an LCR to test it, and a good LCR is going to have the ability to tell equivalent series resistance, which is not something that we would normally document on my end. More important in the electronics part of it, but we don't repair, we replace. So we're never diagnosing stuff on a component level. And it'll also have the ability to change frequency, and we really want something at 10K to 100K to be able to accurately test what it is. Now, some loop detectors will tell you if it can tune the detector to that loop or vice versa, depending upon how it is. So the point that I want to make in this is these are all things that you need to document to actually be able to get a true representation of what the loop is doing and why high potential, high pot, or megging a loop is not the go-to to test it. Not saying don't test it, I'm just saying if you're telling somebody to test it and walk away without understanding what the DC resistance is, then we have a fundamental misunderstanding of how analog circuits work and what that device is actually telling you. Inductance is one, DC resistance is the other. Most digital handheld multimeters will be able to put a couple of volts out and tell you what the DC resistance in ohms. The omega symbol is what we use in the algebraic formulas for that. And you can use an LCR or DMM to do that. So if you're using an LCR to test your inductance of the loop, why wouldn't you just hit the button to select from LC to R and go ahead and test the DC resistance? Well, I don't know why, but apparently Ruben thinks that this is an issue. I would say highly recommend doing that, because again, we're going back to that testing just insulation alone. If it tests good, doesn't mean that you actually have a good loop, which is why you would want to test the DC resistance on this. And this is not gibberish. This is what separates amateurs from professionals, and giving people that are paying you to actually test and document this an overall picture of the loop. And it could separate you from an amateur and a professional. And this is what I would go to in an HOA situation where I'm telling them that they're about to spend $3,200 to replace 3 loops, that they want to have a clear picture of what's going on. In addition to other factors, changing out harness, changing out loop detectors, making sure that the coil is wet when you test it, and so on. These are some of the things that I'm using as far as the test equipment goes, which is what, in my opinion, Ruben is getting hung up on and is so aggressive and rude about his comments, at least his comments to me. So this third thing that we would do is test insulation. And basically what that is the quality of the insulator from the conductor to ground or to another part of a circuit. In this case, ground. So through the concrete, through the rebar, through the ground, back to where our ground is. And that's another thing. You could have a bad ground, still test the insulation resistance to be good, but because you have a bad ground, you'll never know. I used to back in the day mark where I actually would test ground. I still do that on AC motors, but I don't do it on loops anymore. And every once in a while, I'll also use the equipment. I'll write down the equipment that I use to document it as well too. So insulation resistance, let's real quick go through what that is. We'll use water pressure to simulate it. So imagine you have a soaker hose. So this is the handle on the pipe turned to 1. And this is the handle on the pipe turned to 10. So this has more pressure, physical water pressure, and this has less. And if you're not sure what a soaker hose is, a soaker hose has a bunch of little dots. And when you have the pressure on low, meaning what your digital multimeter would put out, which is a volt to 5 volts, if you put it with less electrical pressure, the electricity that's flowing out of the conductor is just going to have a little bit of energy behind it to actually get to a short. In this case, we're using water pressure, and the water probably you wouldn't even see stream out if you turned it up just a little bit. However, if you turn it up full blast by increasing the electricity from 5 volts to 500 to 1,000, now what you have is water shooting out all over the place. The PSI is increased, therefore water is going to go through those little holes at a higher pressure and just shoot out. And this is how you water your lawn, your foundation, and so on. So now let's imagine that's 5 volts, this is 500 volts, and this is concrete that is surrounding the loop, and this is your gate operator. So what now has happened is when you put your lead on the conductor and your lead on ground, this is your insulation tester. So we got one lead going to the conductor and we got one lead going to the conductor. So this is the same test, just doing it on DMM or your meg ohm meter, Megger for short. If you're putting out 500 volts DC, you're going to get electricity that actually grabs onto, if you will, flows, right? Flows to the concrete, through the dirt, and then back to ground. That is what our test will actually show, is that there's electricity flowing, and it'll show 20 megohms or below that, or whatever the case may be. And if not, then it'll show higher, 40, 50, 60 megohms, up to what we've documented here, above a gigohm. Low pressure, you may not ever actually see anything with your DMM because it's not putting out enough electrical pressure. High pressure, electricity shoots out, hits the concrete, hits the rebar, hits the earth ground, and then goes over. This is why it's so important to actually wet the loop with H2O. You need to put water on here and you need to put water on here. And that is the ability to see if there is damage in the insulation. Now there's a little trick to that, and this is where Ruben's logic is flawed. Well, and a couple other places it's flawed as well too. But this is where his logic is flawed. He is suggesting, from what I can gather, all of this 66% of what I'm saying is gibberish. And this is what my contention is, based on past performance and field experience, not off of PowerPoint. So we have a loop in the ground. So we have a coil. That coil comes back. Here's the drive. Here is your home run. Here is conduit. And here's your wire. Insulation is the best it can be in this scenario. All right, do you see where the fault is? So if you test from here, this through the conduit, you could have a break right here. You put your wire generally just on one lead and you test the insulation using insulation resistance meter, so Megger. If you put your lead, here's your gate operator. Can you see that? Yeah, here's your gate operator. If you've got your insulation resistance tester, you got one on ground, one on the wire. What's your insulation test gonna be? Perfectly good insulation. What's your insulation test gonna be? Well, it's gonna be greater than 1 gigohm, right? You have a bad loop, but your insulation test is greater than 1 gigohm. And where do we need to be? 40, 50 million ohms? Do you see this kind of breaking down in your head now, Ruben? Where you're flawed in your logic, where these two other devices will lead you in the direction of the quality of the loop. You have your meter on one lead, your Megger on one lead, you get above a gigohm. So in this case, exit, red, above 1 gigohm. You have one of only 3 faults, which I'm assuming you don't know only three faults that a conductor can have. You have one of 3 faults. Which one is this? I'll give you 5 seconds. If we take our conductor and push it to that, this last, let's just say 2, 6, 12 inches is tested using our Megger. What will we get? It's not touching the conduit, it's not touching earth ground, it's not touching the concrete, it's not touching rebar. What do we get? We get above 1 gig ohm. Is this a good loop? No, it's actually not. So why would we test DC resistance? Why would we want to know a circuit has continuity? For this exact reason right here. Now, where does this actually happen in practical terms? You run your loop through the curb, right? Somebody comes along with the weed eater, hits that. You go to test this conductor and it's cut right there. Guess what happens? It's quite possible you could read 1 gig ohm and still have a bad loop. Is this kind of like sinking in why you would want to get a full picture of what an actual loop is? So if you tested your inductance, you wouldn't have any. If you tested your DC resistance, you wouldn't have any. So why would you suggest to another person that is questioning what we should do with a loop detector or how we would determine if the loop is bad just to do 1/3 of your job? You still want to get paid 100%, but you're only doing 1/3 of your job. And on top of that, you're so vigorous and so blinded by it that even this suggestions you will never say is valid. You will never say that these are valid, right? You're just going to say, well, this is how every manufacturer has taught me to test it. So that's what separates the amateurs from the professionals. This is what separates people walking into an HOA board saying, oh yeah, we've tested all the insulation and all these, they all test good. So I don't think we should go to your loops right now, and me coming in and closing a $3,500 sale to replace 3 loops. And you wonder, well, why did I lose that? He must have been cheaper. So you don't want to go up against me in an HOA board with this because I have a full picture. On top of that, when I do a new install, look at what I've documented. The color of the loop wire, the function of the loop, its resistance, and what its inductance actually is. And if you're just going in there and saying, well, everything worked from the beginning, I have no documentation to prove what it was. And you go in and you go, well, the loop's 30 million ohms. So that's right there on the borderline. No, if it's been 30 million ohms for 10 years, then no, it's actually not on the borderline. It's been that and worked for 10 years. And until you get a good picture of the DC resistance and inductance, it's going to be really hard for you to be able to stand in front of 100 people or 50 people like I did on Friday and convince them that you're the expert. So before you jump the gun, man, maybe it might be worth it to have an open discussion. I am definitely up to being wrong. I'm wrong all the time. I could be wrong a million places in here, but the one thing that I won't do is cower behind a keyboard and say, you're talking gibberish. I'm always open to being wrong. So if you consider this 66% of the test gibberish, please be in the market that I am working in. Please go to an HOA board meeting where we are trying to do our proposals, because I'll win 100% of the time. It's not to insult you, brother, but please don't insult me by suggesting that this is gibberish, because it's not. So Ruben, if you want to get live and talk about these things and prove me wrong, be more than happy to, because I'm willing to be wrong. The difference is I'm accountable for what I say by people not buying my product or trusting me, and you're not accountable. So you could tell anybody anything and it's not going to affect your sales tomorrow. And it is for me. So please call me 214-931-2626 and let's get live and talk about this. Please tell me where I'm wrong, that this other 60%, 66% of getting a good picture of a loop is wrong.